Let's talk about this nuclear reactor small enough to fit in a shipping container, yet powerful enough to run an AI data center or a remote military base for 6 years without refueling. That's exactly what Antares Nuclear just proved is possible. On June 4, 2026, at the Idaho National Laboratory, Antares Mark Zero microreactor reached zero power fueled criticality. This is a perfectly balanced chain reaction where the number of neutrons produced exactly equals those lost. While it generated just a few watts of power to validate core physics, it hits this milestone a full month ahead of a hard July 4th federal deadline. Currently, the industry is stuck in a gigawatt-scale bottleneck. Traditional nuclear plants are massive custom civil engineering projects that take 10 plus years to build and often run billions over budget. And critical sites like military bases still depend on a fragile mix of civilian grids and diesel generators. And when the grid fails, bases flip to diesel, which goes into this endless dangerous fuel truck convoys into remote or hostile regions. Antares is using a different strategy with deployable hardware. Its flagship Antares R1 is a modular microreactor designed to produce 100 kilowatts to 1 megawatt for over 6 years. It uses a graphite-moderated core cooled by sodium heat pipes, which move heat via capillary action with no pumps or moving parts. A nitrogen Brayton cycle, essentially a closed-loop jet engine, then converts that heat into electricity at low pressure to minimize maintenance. The real unlock is TRISO fuel made from HALEU, which is high-assay, low-enriched uranium. Conventional reactors use 3 to 5% enrichment. HALEU is enriched to 5 to 20%, packing more energy into a smaller core. This technology lines up perfectly with global demand triple threat. US military wants resilient power by 2030 through programs like Janus. NASA is targeting 100 kilowatts of fission power on the moon by 2030. The AI industry requires 24/7 carbon-free baseload for hyperscale data centers. The catch is how we got here so fast. A 2025 executive order forced the Department of Energy to fast-track at least 3 test reactors to criticality. Antares hit that mark a month early by reusing decades of Department of Energy R&D, TRISO work from Project Peel, and building a 145,000 square foot factory to mass produce up to 10 reactors per year. That speed raises hard questions about long-term waste, real-world performance of sodium heat pipes at full power, and feather-cutting regulatory red tape also cut critical safety margins as we scale from a quiet test in Idaho to a global fleet of factory power-built reactors from Southern California.